All right, hello everybody. I thought about it and I thought that it would be good for us to go over some problems. I will This will be the first of many. We'll start with homework 1 with functions, and these are some practice problems that should be similar to the assignments that you're given. I'll explain along the way and I'll try not to make it too lengthy, but pause and fast forward is available for these videos as well, and I'll try to remember to put that in the email that I'm going to compose to you about all this. So let's go ahead and get started. So B and C are sets of real numbers defined as follows. So B is V such that V is less than or equal to 2. Let's make a number line for this. And we'll say 0 is right there. We will say 2 is right here. Less than or equal to is like this. And boom. This is, there we go. And this is 2. Then we're going to make another number line here in a different color. You see I'm enjoying playing with my colors here. Number lines are only straight too, by the way, but you know. V is less than 5. So let's just say that's 5 right there. Make it a little thicker. Whoa, it's too thick. Less than. I think it's playing with me a little bit. All right, here we go. Draw open circle. Okay, so let's change this back to that. And since we will be working, we will choose purple. All right, so right B union C and B intersection C, this means union. That means you put these two sets together. This means intersections. That means this is where the two sets overlap. And the empty set is 0 or O with a slash through it. That stands for the null set. You'll probably not know. That's future excitement for some of you. All right, so B union C. Union C. Okay, so interval notation, both of these go back to negative infinity. All right, if I put me here and start walking to the left, both of these go back to negative infinity. When I start walking back this way, if I combine both these sets together, then the overlap ends at 5. So we'll put 5 there, and we're going to put a parenthesis. And the parenthesis means that it does not include the number 5. It gets infinitely close to 5, but it doesn't include it. Okay, and then B intersection C. This is where the two sets overlap. Okay, so what we know is that the blue is included in the red. So that's the overlap where they're included. So that is negative infinity to 2. And the bracket means that we include 2. That's problem number 1. All right. Problem number 2, factor x squared minus 8 minus 20. All right, there are two ways to factor. There are a bunch of different ways to factor this. It's not just 2. There's a bunch of them. The way that I do it is similar to the AC method, which is what are the factors of negative 20? So really it's the factors of 1 and negative 20. 1 times negative 20, which is negative 20. So I got negative 20 in 1, 20, negative 1. Negative 10 in 2, 10 and negative 2. Negative 5 and 4, 5 and negative 4. That should be about it. So what of these two numbers add to equal negative 8? That would be these guys. So that means that my factors would be x minus 10, and x plus 2. That would be my answer. Actually, put a box around those two. Again, this is the way that I learned how to do it, and we do it in our head really quickly. There's an AC method. There's a bottoms up method, a bunch of different ways. This is the most straightforward way to me, but let me know, and we can discuss other ways if you'd like. Factor this. Okay, so 5 times 2 is 10. So 5 times 2 is equal to 10. We're trying to find positive 10 as well. So we're trying to find factors that equal 7. And because it's 2 pluses, we don't need to mess with negatives at all. So that is 10 and 1, 5 and 2. Obviously, those guys. All right. But you see that 5 is in front of the y. So we know that we have 5y plus something, and then y plus something else. Okay. So 5 and 2 are my numbers, but 5 is already dealt with by this 5 here. So I can put a 1 there, and I can put a 2 there. And 5, 7, yep, that would be my answer. Again, we can discuss that more if we need to. Number 4, factor completely. Okay, so the first thing we do when we're factoring is we look for the greatest common factor. Both of these numbers are even, so I can take out a 2. So with 2, so I end up with 2 times 25 minus 9y squared. So there's a property called difference of squares. That's a squared minus b squared. That's equal to a plus b times a minus b. Okay, so this is the same thing as, we make sure you keep your 2. 25 is 5 squared, and 9y squared is, 9 is a perfect square, there's 3, and y squared is a perfect square. Okay, so we have a squared minus b squared. So 5 is our a, 3y is our b. So keep your 2. So we have a plus b, 5 plus 3y, and a minus b, 5 minus 3y. Boom, and that is my answer. I know I hope that I'm not moving too fast for you. Feel free to pause it and all of that other good stuff. Y'all are not here for me to say, hey, you're moving too fast. But if so, yeah, you can pause and rewind and ask more questions about it. All right, find all excluded values for the expression. That is, find all values of y for which the expression is undefined. Okay, the expression is undefined when the denominator equals 0. So in other words, 2y minus 8 has to be equal to 0 for that to be undefined. If we add 8 to both sides, we get 2y is equal to 8. Divide both sides by 2, we get y is equal to 4. That's my answer. And there is only one value because that's a linear equation. There's only one solution to it, if any. Well, technically, it's either no solutions, one solution, or infinitely many solutions. But we'll deal with that when we need to, if we need to. All right, solve for u, another factoring thing. So we have all positive, so 15 and 1, 5 and 3. 5 and 3, obviously add to equal 8. So I end up with u plus 5, u plus 3 equals 0. No, it says solve for u. We have an equal sign here. So it means we need to find what is u. We actually need to get the values for that. So there are two possibilities. I have u plus 5 equals 0, or I have u plus 3 equals 0. Subtract 5 from both sides, and I get u is equal to negative 5. That looks like a 4. And subtract 3 from both sides, and u is equal to negative 3. Okay, so we can leave it like this. We'll put it together. Solve the inequality for y. Simplify your answer as much as possible. Okay, so 37 not equal to, is greater than 12 minus 5y. Solve it like any other equation. Subtract 12 from both sides. 37 minus 12 is 25. Negative 5y. Divide by negative 5. Now, this is where the trick comes in. Whenever you divide by a negative number, you switch to inequality. So I get negative 5 is less than y, or y is greater than negative 5. All right, you can leave it in the first way if you like, but really we're supposed to write it this way. Okay, question 8. For each graph below, state whether it represents a function. So functions are determined by the vertical line rule. In other words, there should be no place that I can draw a vertical line on the graph that crosses the graph in more than one place. If that situation occurs, it is not a function. So, do this right. So, vertical line, no, not a function. Obviously, no, not vertical line, yes, a function. That's future excitement. We'll deal with that later. No vertical lines, yes, it's a function. Vertical line, no, not a function. Believe it or not, this is called a piecewise function. So that is a function, because everywhere there's a point here, that open circle means that it's not included in that. So yeah, that is a function. For this one, vertical line, no, it's not a function. I hope that was helpful. Those types of problems aren't very bad. All right, the function h is defined as follows. Find h of 5. So this is h. Then h of 5 means we put a 5 everywhere that there is an x. So this is equal to 5 squared minus 12 times 5 plus 27 over 5 plus 9, which is equal to 25 minus 60 plus 27 over 14. If you're using a calculator for this, I would do each one, the top and the bottom, separately. You can do it together if you make liberal use of parentheses, but by the time you do all that, in my opinion, you could have just gotten the answer. So I end up with negative 8 over 14, which if you divide both by 2, you get negative 4 over 7. Okay, important part is h of 5 means I put a 5 everywhere there's an x in this. Number 10. All right, so let's do it Let's do it some more. So, man, I need some more space. Okay, I can do this. Yep, we'll do it up here. So f of 6. We'll try to do it like this. F of 6 is equal to the absolute value of negative 12 plus 1/3 times 6. Then the absolute value bar don't have to be that big. All right, it's equal to the absolute value of negative 12 plus 6 times 1 is 6, divided by 3 is 2. Is equal to the absolute value of negative 10, which is 10. 1 down. G of 4. G of 4 is equal to the square root of 4 minus 1 minus 2. 4 minus 1 is 3. Square root of 3 minus 2. That is all we can do with that. We can't do anything else with that. Okay, yes, in 4, I don't know how Alex would deal with it, but just for your mathematical knowledge, when I write this, I would normally write this as negative 2 plus root 3. Okay, again, you can leave it like this for Alex, but you want to make sure that that minus 2 is not underneath that radical. If you're working fast, sometimes, that radical line gets kind of long, and then you end up including that, and your answer's not right. From experience. H of 3. H of 3. Sorry, let me hold this. H of 3 is negative 3 plus 3 squared over 5 plus 3, which is equal to negative 3 plus 9 over 8, which is negative 3 plus 9 is positive 6 over 8, which is 3 over 4. That wasn't bad at all. It wasn't bad at all. I thought it was going to be worse. Oh, go back up here so you can see the answer. Okay. For number 11, h of x minus 2. All right, let's do it. So h of x is that. So, whoops, I didn't mean to do that. So, h of x minus 2 is same principle. 9 over 6 times x minus 2 squared minus 7. Okay, hold on, let me get this right. Okay, there we go. All right. So this is equal to 9 over 6 times x squared minus 4x plus 4 minus 7. Okay, that is 9 over 6x squared. You distribute this 6 to each term. That is the distributive property. 6x squared minus 24x plus 24 minus 7. So that is 9 over 6x squared minus 24x plus 17. I want you to note that when we're doing these problems, we're not approaching this, well, that would go there. We're not approaching these problems trying to manufacture a solution and make it be anything other than what it is. We're just going at it kind of open, and then we see what we get. Okay. All right, here are the functions. F and G are defined as that. For each function, find the domain and write each answer as an interval or a union of intervals. So the first step, whenever you have a function like this is called a rational function. The first step is always to factor everything. And I know you're like, why are you so emphatic about this? Because it's that important. You factor everything. Okay. So this becomes, let's write in a different color. I prefer blue to red. Red makes you think about getting problems wrong. So you end up with x minus 2 over x squared minus x minus 2. If you factor that, you end up with x minus 2 and x plus 1. X squared minus x minus 2. All right. Your domain restrictions on rational functions are any number that make the denominator equal to 0. That would obviously, in this case, be x equals 2 and x is equal to negative 1. So your domain cannot include those numbers, but it includes every number except those numbers. So in order, you would go from, I got you. Let's draw a number line. And this is just for understanding. Negative 1, 2. Can't be that number. Can't be that number. But it is, let's just see if we can make this do right this time. It is all of this, and all of that. What does that look like in interval notation? Glad you asked. The reason that I drew the number line is because the number line helps you understand the interval better. So I end up with negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. That is this area, and this area. That's f of x. G of x, same thing. Okay, I want you to notice that you have an x minus 2 here and an x minus 2 there. You do not cancel these out when you're finding the domain. You do not cancel them out. Okay, so for g of x, just change colors. Let's do a nice green. All right, so I end up with x minus 8 over, this factors into x plus 8, x plus 8. Okay, and you can double check that. That's what it is. So in other words, this denominator is 0 when x is equal to 8. I'm sorry, negative 8. Let's make that look right. Negative 8. Okay, so I won't draw the number line this time. Actually, I won't be lazy. I'll just draw the number line this time. Negative 8. So let's do a darker color. And let's make it bigger. So negative infinity. We don't include negative 8. And then we go into positive infinity. So if we're doing that as in interval notation, and again, the number line helps us understand it, we have negative infinity to negative 8, union negative 8 to infinity. Okay. So again, the number line, and when I normally do it, I'm rushing and it's kind of standing up weird. But when I'm doing this, I normally put the union signs right up under where this is, so I know what I'm talking about. Like it's right that they're lined up, so it makes sense. Let's continue. Just have to prolong this video. H of x is this. Write your answer using interval notation. Well, one of the things that we know about square root functions or radical functions is that the number underneath the value underneath the radical has to be greater than zero. I mean, greater than or equal to zero. Otherwise, it goes into the imaginary numbers. So that means that 36 minus 9x has to be greater than or equal to 0. Little algebra. Negative 9x is greater than or equal to negative 36. Divide by negative 9. And that means that x is less than or equal to, we got to switch it, 4. In interval notation, that looks like negative infinity to 4, but we include 4. That is what that looks like. All right, here we go, more domain. But I feel like we have begun to grasp this a little bit because we know here by looking at this function that negative x plus 9 cannot equal 0. That's when that is a domain restriction. All right, subtract 9 from both sides, even though you may be able to see it. Negative x is equal to negative 9, so positive x is equal to positive 9. So x cannot equal 9. So that is negative infinity to 9 union 9 to infinity. That is the domain for f of x. Wait a minute. We have another situation here. They tried to trick me. Okay, we have a radical here. This has to be greater than or equal to 2. I mean, greater than or equal to 0. So if x minus 2 is greater than or equal to 0, add 2, it means that x is greater than or equal to 2. So in other words, it is the intersection of these two sets. So if x is greater than or equal to 2, that means I can't go back to negative infinity. I can only go back to 2. So let's change our color here, orange. So we are not going to go back to negative infinity. Actually, just cross this whole thing out. We will say 2 to 9 union 9 to infinity, because x has to be greater than or equal to 2. All right, so I guess that is a object lesson to read the whole problem before you start jumping in. Let's just make this all orange. This is the answer. Okay, check your work. Check your work. Don't rush through it. Don't rush through it like I do sometimes. All right, here we go. 15 word problem. We love these. So Bill spends $15 each time he travels the toll roads. He started the month with $225 in his toll road account. The amount $8 that he has left in the account after T trips on the toll roads is given by the following function. So they actually give us the function. Okay. So how much money does he have after 9 trips on the toll roads? So that is A of 9. And that is equal to 225 minus 15 times 9. You can put that in your calculator exactly like that. I mean, parentheses and everything. And you end up with $90. Okay. How many trips on the toll roads can he take until his account is empty? Okay, so that means that 225 minus 15t is equal to 0. In other words, there's no money in his account. Let's solve that. Minus 225. You end up with Negative 15t is equal to negative 225 divided by negative 15. I know what this is, but you know, you can never be too sure. And you get t is equal to 15. So 90 and 15. All right, almost there for this one. The graph of the function shown below, find f of negative 3 and find one value of x for which f of x is equal to negative 2. So f of negative 3, that means I go to negative 3, and at negative 3, my y is equal to 4. Okay. For here, we want to find f of x is equal to negative 2. So there are two values that where f of x is equal to negative 2. Here and here. So that is x can equal negative 4 or x can equal negative 1. They only ask for one, but I gave you both of them. Okay. So the difference in these is f of negative 3. That means this is your x value that you're putting in. F of x is equal to negative 2. That means that this is your y value. All right. Question 17. The entire graph of the function h is shown below. Write the domain of and range of h as intervals or unions of intervals. So the domain is all possible x values. So I start at negative 3, but it's not on negative 3 because it's an open circle. So negative 3 to negative 2. Again, close parentheses because it's an open circle. I mean, open parentheses because it's an open circle. And then from 3 to 5. Union from 3 to 5. That is the domain. The range, we do the same thing, only with the y values. So negative 4. And then you see how it crosses here? That means that that means that the range doesn't break. There is a value there. So it doesn't break from negative 4 to positive 4. Because there's a y, once I get to negative 4, there's a y value, or my function is defined at every y value up to positive 4. So if it's defined there, that means that it is in the range. Go up and down. All right. And question number 18 of 18. Okay, so this is a big problem. Ashley wanted to study how the area of the rectangle changes with the length if its width is fixed. She computed the area of several rectangles that have the same width and different lengths. She then plotted the results and connected them with a line as shown below. The graph shows the area in meters squares versus the length in meters. Find the range and domain of the function shown. All right, so my domain, I don't know what I was doing there. So my domain, they don't say interval notation, so I use inequality notation if I can. X greater than or equal to 0. Range, y greater than or equal to 0. Because there's a point at 0, 0. All right, so that is homework 1. All right, I hope it was helpful. Rewind and pause as you need to.